so that we can connect it. I'm going to show you what is happened in the networks and how today's networks are creating, and because of that we can better understand the functions of different things in the for example network. This is the same scenario, but now in this scenario, as you can see, I am using the switch. Again, let me to assign one IP address to PC3, 192.168, for example, 1/24, and the PC4 again 192.168.12/24.255.255.255.0. Look at here. Now, if you send traffic here, you can see that we have reachability to the 192.168.12 without any problem. And if you go to the simulation mode, you know that the switch should forward for example, traffic only to the specified ports, only to the destination receiver port. Look at here. This is the function of switch, more efficient. But you know that if the PC3 is sending one broadcast, for example, if you check the connectivity with the 192.168.13, the first thing that should be created is the ARP request. Let me to capture the ARP request also. Again, sending the traffic from the PC3 to the 192.168.14. Okay, this is the PC3. Okay, ping 192.168.14. We should send traffic to the 14. Very good. Look at here in the simulation, we should send. Here you can see the ARP request. As you know, the ARP request is flooded because this is broadcast, and this means that the switch by default doesn't limit the broadcast, and all of the interface on one switch is residing in one broadcast domain. Okay, and we need to control the broadcast domain size with the concept of VLAN. You have learned about the VLAN, and you know that what is the VLAN. But before talking about the VLAN, you know that in the hub topology and also in the for example switch topology, in these two topology, we are using actually the star topology. Why? Because you know that in a star topology we have one central device and some devices that connect to that central device. Because of that, with the hub and switch, both of them we are using the star topology. When you are using hub, you have one collision domain and also one broadcast domain. When you are using the switch, you have multiple collision domains and only one broadcast domain. But you know that with the define of the VLAN, as you have learned in this class, for example, completely, we can reduce the size of the broadcast domain and increase the number of the broadcast domain. For example, here you can see this switch has three interfaces. Let me to show you. For example, this is the interface 1, fast Ethernet 01, fast Ethernet 01. This is the for example, fast Ethernet 02, and this is the fast Ethernet 03 interface. And here we have for example, fast Ethernet 04 and then fast Ethernet 05. You know that by default, all of these interfaces are residing in one VLAN or VLAN 1, and because of that, all of them are working in one broadcast domain. But with definition to VLAN and assigning the VLAN to VLAN 1, the VLAN 1 to port 1, 2, and 3, and the VLAN 2 to port 4 and 5 and 6, finally we can say that we have two VLAN, and each VLAN is a broadcast domain. And this means that now we are reducing the size of broadcast domain, and you know that this can give us the benefit of controlling the traffic. This is one broadcast domain, and this is another broadcast domain. You know that again here we have 6 collision domains. Each port is a collision domain, but about the broadcast domain, now we have 2 broadcast domain. The switch by default has only one broadcast domain. If you need to create a broadcast domain, you should configure it. You have learned about it. Also, as you can see, in each broadcast domain, we are using one range of IP address differently from the other broadcast domains, because you know that finally between the VLANs, between the broadcast domains, we need to configure inter-VLAN routing, and inter-VLAN routing needs to, the networks are using the different range of IP address. Okay, this is the history until the creation of the VLAN. But you know that we have many devices in one network. For example, maybe you have multiple switch with multiple hosts connected to that switch. Okay, how we can connect switch together? In most cases, we are using a two-level or a two-tier hierarchy. Why? Because, for example, assume that we have switch B with multiple VLANs, switch C with multiple VLANs, again switch D, again switch E, and we need to connect all of these devices together. Because of that, we need a higher level switch to connect these switches together. Because of that, after the, for example, growing the networks, for example, we have used the higher level in the switching, in the switch design in the LAN architecture, and now we have a two-tier, for example, design. Look at here. This is the two-tier design or two-tier hierarchy, or maybe two-level hierarchy. All of them are correct. Let me to write here two-tier design. Okay. Or maybe you see two-level design, or maybe two-tier design. All of them are correct, okay? After that, here in this design, you can see we have some switch that these switches are connecting to the hosts. And also we have one switch, the switch A, that its function is the connecting for example, switch B and C together. Not the switch A does not connect to the, for example, host, okay? In the design of the LAN, we are calling the switch B and switch C, okay, the access layer switch. Here we have two access layer switch. This is one access layer switch, and this is another access layer switch. Why we should call them access layer switch? Because they are connecting the hosts of the network to the network. This means that we are giving access to the host to connecting to the network. Actually, we can say the access layer switch provides a connection point for end user devices to the network and does not forward frame between two other access switch under normal circumstances. We don't forward traffic directly between the two access layer switch. We are using another layer, the higher layer. This higher layer name is the distribution layer switch. You know that the function of the switch A only is distributing traffic from one access layer switch to another access layer switch. Because of that, in the distribution layer, we are providing an aggregation point for access switch, providing connectivity to the rest of the device in the LAN. For example, with distribution switch, you can connect to the other device in the LAN and forwarding frame between the access layer switch, but not connecting directly to the end user devices. You know it. Because of that, until now, we have learned the history of the LAN, or for example, the local area network, until we reach to the two-layer hierarchy or two-tier design. Okay, but again, maybe we encounter with another layer. Let me talk about that. Until now, from the same one collision domain, one broadcast domain, we have received to the multiple collision domain, one broadcast domain, again multiple collision domain, multicast broadcast domain, and finally the two-tier design. Okay, now you know the history. Let me to continue the story of the LAN architecture. Okay, in the left side, you can see again the two-tier hierarchy or two-tier design. We have switch B with multiple VLANs, VLAN 1 for computer, server, and printer, VLAN 10 for voice VLAN for the IP phones, VLAN 2 in switch C for computers, and VLAN 20 is the VLAN for the IP phones again, or voice VLAN again in the switch C. Okay, and now we have a higher level switch, the distribution layer switch. Okay, actually you have this single line diagram, distribution layer switch and also access layer switch. You know that now we have multiple access layer switch and maybe one distribution layer switch, but you know that the network is growing day by day, and after growing, for example, the network to have multiple, maybe more than 50, 100 access layer switch, maybe we need a other higher level. Why? Look at here, we have some access layer switch here with one distribution layer switch, again other access layer switch here with one distribution layer switch, and now we want to connect these two distribution layer switch to each other. Let me to give you one real example. Assume that here we have a building. This is the building 1. Okay, in building 1 we are using the for example one distribution layer switch and also multiple access layer switch. This is the building 1, and also in the same place, in the near place, okay, we have another building. Assume that here we